In this session, we are going to discuss about the production of KBS or SURF. Before going to that, what we have discussed in this unit so far, we will just recall that we have seen the properties, physical properties and composition of oils, the acid value, saponification value, and iodine value of oils and fats. And we have seen the methods of extraction of vegetable oils. There are two methods: mechanical expression method and solvent extraction method. We have discussed both of these methods in detail. In mechanical expression method, all the seeds are actually cleaned. It means oil seeds are cleaned and dehulled, and the meat from the oil seeds is actually cracked or sliced, and then it is fed to a digester or a cooker where it is cooked at a temperature of 110 degrees Celsius. After cooking, the oil is actually fed to an expeller to remove the oil from the cooked meat. After separation of oil, the solid material obtained is known as oil cake, which can be taken out, dried, and used as animal feed. The oil thus obtained from the expeller is actually cooled and it is further processed, and in the solvent extraction process the cleaning of oil seeds is done and it is actually dehulled, and then it is cut into narrow sets or slices, and then it is fed into an extractor. The extractor works on countercurrent basis. The solvent, that is hexane, is sprayed on the top of these cossets or the slices of oil seeds, meat, and then the solvent actually diffuses into the oil glands and takes out the oil or dissolves the oil in the solvent, and a solvent oil mixture is obtained which is known as micella. This solvent oil mixture is subjected to filtration in a rotary drum filter to separate the extracted oil and the solid material, that is oil cake. The filtrate, that is oil obtained, is then processed. In the processing of the oil, there are three steps. That is, one is degumming process, removal of gum in this by chemical treatment. Then bleaching is done with an diatomaceous earth or kisel goo. An adsorbent is used for that, and hydrogenation is carried out, and dewaterization of oil is done by filtering over a bed of activated carbon, or activated carbon is mixed in the oil and then filtered. In the hydrogenation process, the unsaturated fatty acids are converted into saturated fatty acids by the addition of hydrogen. The purpose of hydrogenation are to remove the double bonds from the fatty acids, to improve the melting point or to raise the melting point, to saturate the oil, and fourth one is to prevent the oxidation of oil, rancidity ಅಂತ ಕರೀತಾರೆ. rancid oxidation ಅನ್ನು ಪ್ರಿವೆಂಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೈಡ್ರೋಜನೇಷನ್ ಮಾಡ್ತಾರೆ. Hydrogenation is carried out at a temperature of 180 to 190 degrees centigrade in presence of nickel catalyst. ನಿಕ್ಕಲ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ನಿಕ್ಕಲ್ ಫಾರ್ಮೇಟ್ ಅನ್ನ ಡಿಕಂಪೋಸ್ ಮಾಡೋದ್ರಿಂದ ನಿಕ್ಕಲ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಅನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾರೆ ಇನ್ ದಿ ಆಯಿಲ್ ಬೇಸ್. ಈ ನಿಕ್ಕಲ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಮತ್ತು A oil which is to be hydrogenated is fed to a hydrogenator and it is heated up to 880 to 190 degrees centigrade temperature. And hydrogen, pure hydrogen, is actually gas. Hydrogen gas is bubbled through it. Hydrogen is produced by electrolysis of water or iron steam reaction, and this hydrogen must be free from sulfur and its compounds, which leads to poison. The hydrogen, the purified hydrogen is bubbled through that, so the hydrogenation takes place. The hydrogenated oil is then taken out, filtered, and then further processed. We also discussed about the soaps and detergents. Soaps are actually chemically, soaps are sodium or potassium salts of fatty acids. Here, sodium hydroxide or potassium hydroxide is used to saponify the fatty acids. These, on saponification, these fatty acids gives soap that is called as base soap. From this base soap, we can produce toilet soap, bar soap, or industrial soap, right? And by adding builders to that to boost the properties of soap, and also they are added with colors and perfumes. Number one is to attract the customer. Number two, to remove the original color and odor of this soap. And then the soaps are actually made into required size and shape by hydraulic pressing. We also discussed about the production of detergent, that is ABS alkyl benzene sulfonate. To produce this alkyl benzene sulfonate, raw material is the hydrocarbon paraffins that are present in the kerosene based oil, that is C10 to C12 carbon atom content paraffins. These are actually separated from kerosene grade of oil, and then it is actually alkylated in the alkylator, and this alkylate is separated by fractionation into heavy alkylate and this light alkylate. Heavy alkylate is used for the production of inferior quality of detergents. High quality detergent is made from light alkylate. This light alkylate is taken out and is treated with oleum or concentrated sulfuric acid, which gives sulfonated alkyl benzene sulfonate. This alkyl benzene sulfonate is then neutralized with sodium hydroxide by the addition of sodium hydroxide, so that excess sulfuric acid or oleum present will be neutralized. Then it is added with builders, colors, anti-redeposition agents, and then it is sprayed, dried to give alkyl benzene sulfonate. Today we'll discuss about the production of chiral benzene, KBS or SURF. This is the flow diagram of production of chiral benzene sulfonate, KBS or SURF. Here, chiral benzene sulfonate is actually made from kerosene-based oils. Kerosene, which consists of C10 to C12 hydrocarbons, is actually fed into a alkylator, sorry, a chlorinator, where the olefins are chlorinated in presence of chlorine, and the hydrochloric vapors produced are separated from that. It is an exothermic reaction, so the reactor must be protected with by the temperature, that is by passing cooling water around it, and then these chlorinated olefins are actually dropped into alkylator, where benzene and aluminum trichloride are added to this, where the alkylation of benzene takes place there. Benzene and alkyl chlorinated olefins actually reacts in presence of aluminum trichloride and produces chiral benzene. This chiral benzene is stored in a holding tank, and then it is actually fed to a series of fractionator to separate unreacted benzene in the benzene column, unconverted kerosene in the kerosene column, and the chiral benzene from the heavy ends is separated in the last column. And the chiral benzene is taken as overhead product, and bottom product contains chiral benzene with heavy ends. The chiral benzene thus obtained as overhead product of this fractionator, the fractionator 6, is fed to a sulfonator where concentrated sulfuric acid is added into that, so that chiral benzene sulfonate is formed. This chiral benzene sulfonate is actually fed to an separator to separate the spent acid, and then this chiral benzene sulfonate is fed to a neutralizer where sodium hydroxide is added to that, which actually neutralizes the excess sulfuric acid present in that. And finally, this chiral benzene sulfonate, which is in the liquid form, is spray dried in a spray dryer and gives powdered chiral benzene sulfonate or sulf. Let us see the process. All household detergent in India are manufactured from paraffins found in kerosene range of fractions. ಕೆರೋಸಿನಲ್ಲಿ ಸಿಗುವಂತ ಪ್ಯಾರಾಫಿನಿಕ್ ಫ್ರಾಕ್ಷನ್ ಇಂದ ಎಲ್ಲ ಹೌಸ್ ಹೋಲ್ಡ್ ಡಿಟರ್ಜೆಂಟ್ಸ್ ಅನ್ನ ಇಂಡಿಯಾದಲ್ಲಿ ಮಾಡ್ತಾರೆ. These fractions are rich in aromatics. The aromatics can be separated either by adsorption or desorption process and desorption process. Absorption ಆಗಿ ಆಮೇಲೆ ಸಪರೇಷನ್ ಮಾಡಿ ಡಿಸಾರ್ಪ್ಷನ್ process, liquid extraction or by acid destruction method. ಯಾವುದೇ ಒಂದು ಮೆಥಡ್ ಇಂದ ಅದನ್ನ aromatics ಅನ್ನ ಸಪರೇಟ್ ಮಾಡಿ ತೆಗಿತಾರೆ. Kerosene range paraffins are first chlorinated with chlorine in a mole ratio of paraffins 1 is to 3 chlorine molecules to 1 is to 10, 1 is to 3 to 1 is to 10 ರೇಷಿಯೋದಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ, paraffin and is to chlorine. Chlorination is carried out in the liquid phase. Usually, 2 reactors are used in series for chlorination. ಎರಡು ರಿಯಾಕ್ಟರ್ ಅನ್ನ ಸೀರೀಸ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Excess chlorine and hydrogen chloride vapors are stripped off and recycled. ಇಲ್ಲಿ ಎಕ್ಸೆಸ್ ಕ್ಲೋರಿನ್ ಏನು ಸಿಗ್ತದೆ ಅದನ್ನು ಉಳಿತದೆ ಮತ್ತು ಅದರಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಆಫ್ಟರ್ ರಿಯಾಕ್ಷನ್ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ವೇಪರ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಎರಡನ್ನ ಸ್ಟ್ರಿಪ್ ಮಾಡಿ ಅದನ್ನ ಆಮೇಲೆ ರೀಯೂಸ್ ಮಾಡ್ತಾರೆ, ರೀಸೈಕಲ್ ಮಾಡ್ತಾರೆ. The unchlorinated paraffins are separated by distillation and recycled to the chlorinator. In ಎಲ್ಲ ಪ್ಯಾರಾಫಿನ್ಸ್ ಕೂಡ ರಿಯಾಕ್ಟ್ 100% ರಿಯಾಕ್ಟ್ ಆಗೋದಿಲ್ಲ. ದಿ ಅನ್ರಿಯಾಕ್ಟೆಡ್ ಕ್ಲೋರಿನ್ ಅನ್ನ ಪ್ಯಾರಾಫಿನ್ ಅನ್ನ ಸಪರೇಟ್ ಮಾಡ್ತಾರೆ ಇನ್ ಫ್ರಾಕ್ಷನೇಟರ್ಸ್. ಹಾಗೇನೆ ದಿ chlorinated paraffin is hydrated and then alkylated with benzene. Chlorinated paraffin ಅನ್ನ ಬೆನ್ಝೀನ್ ಜೊತೆ ಆಲ್ಕೈಲೇಟ್ ಮಾಡ್ತಾರೆ in presence of aluminum trichloride catalyst, so it gives alkylated chlorinated or alkylated product, the chlorinated alkyl benzene. The alkylated hydrocarbon mixture is settled and washed to remove the catalyst, and then separated from remaining hydrocarbons. Then first reaction ಆದಮೇಲೆ ಆ ಮಿಕ್ಸರ್ ಅನ್ನ ಎಲ್ಲ ಸೆಟ್ಲ್ ಮಾಡ್ತಾರೆ. ಸೆಟ್ಲಿಂಗ್ ಆದಮೇಲೆ ಅದನ್ನ ವಾಟರ್ ಜೊತೆ ವಾಶ್ ಮಾಡಿ ಕ್ಯಾಟಲಿಸ್ಟ್ ಅನ್ನು ಸಪರೇಟ್ ಮಾಡ್ತಾರೆ. ಆಮೇಲೆ ರಿಮೈನಿಂಗ್ ಅನ್ರಿಯಾಕ್ಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅನ್ನ ಸಪರೇಟ್ ಮಾಡ್ತಾರೆ. ಕ್ಲೋರಿನ್ ಮತ್ತು HCl ಕೂಡ ಇಲ್ಲಿ ಸಪರೇಷನ್ ಮಾಡ್ತಾರೆ. ಎಕ್ಸೆಸ್ ಕ್ಲೋರಿನ್ ಮತ್ತು ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ವೇಪರ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗೋದು. The alkylate is then sulfonated with H2SO4 or oleum. ಈ ಆಲ್ಕೈಲೇಟೆಡ್ ಬೆನ್ಝೀನ್ ಏನು ಸಿಗ್ತದೆ ನಿಮಗೆ, ಆಲ್ಕೈಲ್ ಬೆನ್ಝೀನ್, ಅದನ್ನ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಅಥವಾ ಓಲಿಯಂ ಯೂಸ್ ಮಾಡಿ ಸಲ್ಫೋನೇಟ್ ಮಾಡ್ತಾರೆ. ಅದರಲ್ಲಿ ಎಕ್ಸೆಸ್ ಓಲಿಯಂ ಅಥವಾ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಇದ್ರೆ ಆಲ್ಕೈಲೇಟೆಡ್ ಆಲ್ಕೈಲ್ ಬೆನ್ಝೀನ್ ಸಲ್ಫೋನೇಟ್ ಅಲ್ಲಿ ಅದನ್ನ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಯೂಸ್ ಮಾಡಿ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡ್ತಾರೆ. ನ್ಯೂಟ್ರಲೈಸ್ ಆದ್ಮೇಲೆ ಅದಕ್ಕೆ ಬಿಲ್ಡರ್ಸ್, ಪರ್ಫ್ಯೂಮ್ಸ್, ಕಲರ್ಸ್, ಆಂಟಿ ಡಿಪೋಸಿಷನ್ ಏಜೆಂಟ್ಸ್ ಇವನ್ನೆಲ್ಲ ಅದಕ್ಕೆ ರಿಕ್ವೈರ್ಡ್ ಪ್ರಪೋರ್ಷನ್ ಹಾಕ್ಬಿಟ್ಟು ಮಿಕ್ಸ್ ಮಾಡ್ತಾರೆ. ಆಮೇಲೆ ಈ ಸ್ಲರಿ ಏನ್ ಸಿಗುತ್ತೆ ನಿಮಗೆ ಅದನ್ನ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಅದನ್ನ ಸ್ಪ್ರೇ ಡ್ರೈಯರ್ಗೆ ಹಾಕಿ ಸ್ಪ್ರೇ ಡ್ರೈ ಮಾಡ್ತಾರೆ. ಅದರಿಂದ ನಮಗೆ ಡಿಟರ್ಜೆಂಟ್ ಪೌಡರ್ ಸಿಗ್ತದೆ. ಇದು ಕೆರೈಲ್ ಬೆನ್ಝೀನ್ ಸಲ್ಫೋನೇಟ್ ಅಥವಾ ಸರ್ಫ್ ಅನ್ನು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡುವ ಪ್ರೋಸೆಸ್. Let us see some of the MCQs in this session. 1. Presence of sodium tripolyphosphate in synthetic detergent. Dash. A. Facilitates its use even in hard water. B. Inhibits the corrosion effect. C. Does not allow redeposition of dirt on washed surface. And D. None of these. Presence of sodium tripolyphosphate in detergent. Dash. Right options is option A. It actually detergent facilitates its use even in hard water. Question number B or 2. Carboxyl methyl cellulose MCC is added in detergent to dash. ಯಾಕೆ ಕಾರ್ಬಾಕ್ಸಿಲ್ ಮಿಥೈಲ್ ಸೆಲ್ಯುಲೋಸ್ ಅನ್ನ ಡಿಟರ್ಜೆಂಟ್ ಅಲ್ಲಿ ಯಾಕೆ ಆಡ್ ಮಾಡ್ತಾರೆ? Options A. Prevent redeposition of soil on clean surface. Option B. Acts as optical brightening agent. Option C. Inhibits corrosion in washing machine and made of aluminium. And D. None of these. ಇಲ್ಲಿ ಸರಿಯಾದ ಉತ್ತರ ಆಪ್ಷನ್ ಎ. ಅದು ಇಟ್ ಪ್ರಿವೆಂಟ್ಸ್ redeposition of soil on clean surface. Question number 3. Hydrophilic group of soap or detergent solution is dash. Options are A. Water hating, B. Soil loving, D. Water loving, and D. None of these. The right answer is hydrophilic group of soap or detergent solution is water loving. Option C is the right answer. Next, question 4. Fluorescent dyes are added in detergents to dash. Fluorescent dye ಗಳನ್ನ ಡಿಟರ್ಜೆಂಟ್ ಅಲ್ಲಿ ಆಡ್ ಮಾಡ್ತಾರೆ. ಯಾಕೆ? ಆಪ್ಷನ್ ಎ. Acts as fabric brightener. B. Attains distinctiveness from other brands. C. Acts tarnish inhibitor for metals like German silver. And D. None of these. Answer here is answer A. That acts as fabric brightener. Question number 5. Alkyl benzene sulfonate ABS is a dash. Option A. Detergent. Option B. Plasticizer for unsaturated polyester. C. Starting material for glycerine. And D. Coating ingredient for photographic films. Here, option A is the right answer. Alkyl benzene sulfonate is a detergent. Thank you.